In this video, we're going to look at sequences, general formulae and recurrence relations. So the first example we'll take a look at is write the first four terms of the following sequence. UN equals 3n minus 4. And so the sequence we were given, the general formula is UN equals 3n minus 4. So with this explicit formula, we'll just substitute U1, 1 for n, 3 times 1 minus 4 is negative 1. So the second term, U2, 3 times 2 minus 4 is 2. U3, so we simply substitute numbers 1, 2, 3 and 4, and then we have written the first four terms. So here we've got 9 minus 4 is 5, and the fourth term, U4, equals 12 minus 4 is equal to 8. So that's what we required, the first four terms, and it's quite a simple example of using a general formula. The next example we'll take a look at is that to show that the following recursive sequence is periodic. And the sequence are given is UN plus 1 equals 1 over 4 on 3un squared minus 2un minus 8, where u1 is equal to 2. So we'll take a look at that example. It's a recursive sequence. I'll just note the sequence here. It's un plus 1 equals 1 over 4, and we'll open the bracket for the quadratic inside is 3un squared minus 2un minus 8. And we are told that u1 equals 2. So in the recursive sequence, we're given un plus 1, which means if we know u1, we can find u2 by subbing u1, the value of u1 in for un. So we're going to have 1 over 4, 3 times 2 squared minus 2 times 2 minus 8. And we go ahead and calculate that. Now I'm going to set this up on the calculator in such a way that will enable us to easily calculate subsequent terms. So I'm just going to put in 1 over 4, open brackets, 3 times, and I'm going to put my value of u1, which is 2, in brackets, minus 2 times 2. So I'm setting up the whole equation here as we're given it, and close brackets. And the u2, which is what we've got on the screen here, u2 equals 0. So I'm going to write that clearly here, u2 equals 0. Now we're going to look for u3 by subbing u2 in for every time we have un, and on my calculator I'm just going to edit the calculator, delete out the 2 and just write answer in where 2 is. Where our un is, we will write answer. So I have it there twice. Now the calculator will automatically take the previous answer, which was u2 of 0. So I'll hit equals, and I get u3 then equals, I'll write it over here, u3 equals negative 2. Now if I bring up the calculator once again and hit equals, then the calculator will use u3. It should be using u3, but hold on, have we done something incorrect? Let me check that. I see the problem. I've actually put 2 times in here. Let me just go back and delete that 2. So that will obviously return an incorrect answer here. So maybe instead of answer, I'm just going to put my -2 in, -2, and move along on the formula, -2. And if U3 is -2, that should tell me that U4 will be, let me go back and see. Okay, I'm 1 bracket, 2 few here, so open bracket and 3. I think that should be correct. Good, so U4 is equal to 2. U4 equals to 2. And we see we're back to U4 is the same as U1, and just to show that it is indeed periodic, I will go back and do that correctly now. Put in the sub-in answer correctly. And each place we have UN. And just have a look there, it is correct. Okay, so U5 is 0, U6 is -2, and U7 is 2 again. So we definitely have a repeating pattern, therefore our sequence UN plus 1 is indeed periodic. So make sure you make that conclusion. And in this case, the period is 3 because the sequence repeats itself after 3 terms. Okay, so let's take a look at the final example. The final example is today is to, for each of the following recursive sequences, show that one is divergent and one is convergent. So we'll just take a look at the first one first. Vn plus 1 equals 12 over Vn plus 1, where U1 equals 5. So we'll take a look at the first recursive sequence is Vn plus 1 equals 12 over Vn plus 1. And V1 we're given is 5. So we'll do similar to the last example in a recursive sequence, we'll sub in the value for V1 first. So we're going to look at V2 now. V2 will be 12 over 5 plus 1. And I'll just set it up on the calculator again. So we have 12 over 5 plus 1. And it gives us 17 over 5. Now I'm going to actually just decimalize that because that way it'll help us see a pattern, a recurrence pattern. So that gives me 3.4. And the next term, V3, we'll be taking the answer. So I'm just going to set it up as 12 over answer plus 1 and decimalize that to see what we get. So we have 12 over answer plus 1 is 77 over 17. When we decimalize it, it does give us, and I'll round this to three significant figures. So it was 4.53. And if we go again now, look at the fourth term, V4. (281 over 77), which will give us 3.6. Is it 3.65. Now we've got a pattern. It's beginning to look like it might be convergent. Just let's look at another, maybe 2 terms to be sure about that. So V5 is, in decimal terms, it's 4.2.29. It looks to me like it may be converging towards 4. Let's have a quick look at V6. 3.7. So you can see it's oscillating around some value between 4.29 and 3.7. So that indicates to me that it is converging towards a limit of perhaps 4. So we'll have a quick look at the calculator, because sometimes if I work out a lot of terms, if I keep hitting equals, I can see the calculator values really are converging towards 4. And the calculator will stop after a time 9 decimal places. It will stop at 4. But yes, this is indeed convergent. So it's approaching a limit that looks to be 4. And the second recursive sequence in this question, maybe just go back and remind ourselves of the second one. The second one is wn plus 1 equals wn squared minus 2wn plus 3, where w1 equals 1. I'll just take a look at that one. Maybe minimize the OBS here. Just minimize that screen there. And the recursive sequence was given by wn plus 1 equals wn squared minus 2wn plus 3. And we're told that w1 equals 1. So the w2 will be 1 squared minus 2 times 1 plus 3. So we can see very quickly that w2 is equal to 2. w3 is 2 squared minus 2 times 2 plus 3. So we 4 minus 4 plus 3. w3 equals 3. w4. So we're going to have 3 squared is 9 minus 6. No. So it's 3 squared minus 2 times 3. So it's 9 minus 6 plus 3 equals 6. So we've w4 equals 6. Now this looks to me like it is divergent, because the more values we put in for wn, the bigger the final recursive value is. So we've 6 squared minus 36 minus 12 plus 3. So w5 is 36 minus 12 plus 3 is 27. So this, if we keep putting values in for wn, we are eventually approaching infinity. This sequence is diverging. It is not approaching any particular constant. It's approaching positive infinity. So we can state after 5 terms that this is definitely divergent. Okay, that's it for this video. Thank you for watching.